Science and engineering I see as being complementary. That science is really trying to figure out how the natural world works through this process of generating and testing hypotheses. Engineering helps scientists devise instruments and tools. Electrical engineering has a lot to contribute in terms of sensors and instruments.
I had like many friends who actually went to ECE departments and took electronics courses to be able to understand and design their own feedback systems.
I'm thinking neuroelectrical circuits and interfaces.
So this robot, you might have seen these in the stores. It was originally developed at a workshop that I occasionally attend, where we get neuroscientists and electrical engineers together, and we try to figure out how to make electrical things that mimic neural systems. So using the ideas in insect brains, the inventor of this developed a very simple circuit that enabled it to walk, dance, run, and various things, and went to a toy company. They wrote him a big check, and he's now, I think, a multimillionaire.
There is a lot of need for people who are interdisciplinary, people who know how to do more than one thing.
Let me tell you what are not robots. So if you turn on TV and you see robot wars, where they have these robots that are being controlled by people, those are not robots. Those are electromechanical puppets. The difference between those and a robot is a robot actually senses something about what's going on in its environment, makes a decision about how to act, and then acts. And so robotics has become this interesting connection between electrical engineering, which is about building devices and systems for sensing, etc. Computing, which is a lot about making decisions about what the system should do and how it should do it. Control, which is a whole branch of engineering that talks about how you build control circuits and systems for controlling mechanical or electrical systems. And in fact, what's sometimes called mechatronics, or the mechanical aspects of robotics. You know, how do you design a hand so that a certain number of tendons can control a certain number of fingers and that kind of thing. So I think if you wanted to get started, one thing to do is to pick one of those areas. Maybe you're really interested in the mechanical stuff. Well, if you're interested in the mechanical stuff, go learn about what it takes to design, say, robot hands. So if you're seeing a robot walking and just trying to figure out how can I get it to walk without falling over on just two legs, which means that it's not balanced. It's actually, you know, you can think of walking as controlled falling, right? I mean, you fall, but just when you're about to fall, your foot's always in the right spot at the right time. That's what walking is, so that's control. You just find it so cool about how a robot can just walk around the room here and not bump into something. That's sort of on the sensing part. The core of the robot is its brain. You know, how does it decide what to do? And that's all about artificial intelligence and making decisions. You know, get a little bit of speed on programming and learning about how to do that, and then building small programs. First do some things based upon you know, just abstract little problems within the computer. But pretty soon hook it up to some sensor. Hook it up to a Connect, and there's open software that'll get your skeletons, so you now know where the limbs of the person are, and get the system to try to decide when to open up a door. So, you know, those sort of four areas of the mechanics, the control, the sensing, and then the thinking, those four areas, you can play in any one of them. See, and it's really not necessary that you pick any one of them to get started, and any of them will be fine. And then if you're more interested later, I would highly recommend connecting with computer science.
So I started out as an undergraduate student, thinking that I wanted to do Earth remote sensing, using satellites to detect the growth of plants or other conditions on the surface of the Earth. I took all the classes there, but I was offered a position to do research in hearing aids, and I guess I've never looked back. A little chance like that, and I've been working in kind of acoustics sound processing ever since. That's where we work out the theory for how you can manipulate sound using algorithms, using computers. So I developed a hearing aid eventually as part of my master's thesis. That technology was acquired by a company that made the hearing aids that my grandmother used. So that was a very satisfying experience for me. So I'm interested in making things sound good. And that involves getting rid of noise that's picked up along with speech and cell phones, to understand what makes sound pleasing and how we can get computers to do that. I have students right now working with me on music processing and speech processing and a variety of other acoustic related things, and these are all in electrical engineering.
You're too young to know exactly what it is that you want to do. So explore different options, explore different fields. You may find something that you previously thought was utterly boring in high school. When you get to college, you find utterly fascinating, and that this is what you want to do for the rest of your life. So explore.